All right, hello there, everybody. I'm just gonna put together a quick little tutorial here just to finish off the stuff we started in the lab last night. Just creating a quick little script that allows you, based on the sizes of the bricks that you're using, to assemble a wall system, a series of planes that can both be used to visualize the wall that you're designing, but also to actually be sent to the robot to locate bricks. Real quick, just so everybody has this, COAA winkey.uncc.edu is the server name that you're going to want to use for connecting to get a Rhino license. And once you've connected to that through the Zoo server prompt that comes up when you install the trial version, you need to fully install it and then try to open it. It should prompt you to connect to a license through a Zoo server. Then that's where you type in this address, test connectivity, and then hit OK when it says it was successful. Again, you have to be on the university's secure network, either on EDU Roam or on Niner Wi-Fi Secure. You can't be on the guest. You can also plug into a Wi-Fi address, or an Ethernet cable on campus. So yeah, let me know if you have any questions about that. So quickly, there were a couple of people having issues with scale with this first part. I like to use this second button, interpolate curves, when I'm drawing things. You may, just before you draw these, want to draw in a line just to get a sense of scale, so that it's appropriate to what you're trying to draw, or you could draw a rectangle. So you can see here my initial line is only 600 millimeters. I'm going to scale that up so that it's about 3,000 millimeters, or about 10 feet. So this gives me a good sense of what to start with. And again, I'm going to turn my ortho off down here. I'm going to use that interpolate curves just to make an S-shaped curve for the base and a C-shaped curve, roughly the same length for the top. And you can kind of play around with these at any point in the script. So in Grasshopper here, quickly, because we went through a lot of this already, I'm going to put two curve components in. Again, these black containers, I'm just typing the word curve and double-clicking, and you'll see that these black containers are actually the things that contain objects from Rhino inside of your script so that you can manipulate them. So I'm going to right-click and say set one curve for this lower one, and I'm going to change the name to, this is lower. And then select the other one and right click to say set one curve, and again change the name to upper. Some sliders we need for each of the different sizes of the bricks. So the width first maybe is 203, excuse me, the length is 203.2, that's 8 inches. In millimeters, 25.4 times 1.5 is 38.1. That's your inch and a half. So we'll call this one height. We'll call this one length. And then 3.5 times 25.4 is 89 and a quarter. And that's going to be our width. We also generated a slider that defined the number of bricks. So I'm going to call this one number of, let's call it courses. Thank you, Glenn. If you right click on this and hit edit, here are the different ways that you can define the sliders. So here as an integer slider, or as a floating numbers, which basically is going to allow you some decimal points, where you can change the min and max on any slider inside of here. I'll hit OK. And then we want to have one last slider, which is the gap. I'm going to start off with that being an inch and a half, but I may want to be able to adjust that, and I'm going to rename that one called gap. Then we've got all the components we need here to get us started. You can use these little adjustments to actually snap things into place and organize your your script as you start to work with it. The first thing we did was to move the upper curve. So I'm going to put that into the G, and I might just adjust this so that upper is on top. And we're going to move it in the Z direction. So I'm putting in a Z component, and we're moving it the height, which is 1.5. And again, this is the first moment where you might notice whether or not your curves are working or your stuff is at the right scale. And you can see here mine are not working at the right scale. My units in Rhino must have been different. So I'm going to scale this down so that it looks just more proportionate. Again, if you've got 20 bricks, oh, excuse me, I didn't do that right. Sorry, that's why things aren't quite right. I need to do a multiplication, right? So the upper curve is actually going to be 38.1 millimeters times 20, which is the number of bricks that we have. Sorry. So now if I zoom out, this looks appropriate. That's about the correct height for what we want our wall to be in proportion to its length. So about 3 times the length as the height. So again, I just put in a multiplication of the number of courses times the height of the brick. And then I can do a loft. So I'm putting in a loft, which just creates a surface. In order to put multiple curves into this loft, I'm going to hold shift as I drag the second one in. If I don't, then it's just going to replace whatever was already going in there. By holding shift, it puts them both in. You can see here my curve is twisted. This is because when I drew them, I drew the S shape going from left to right, and then I drew the C shape going from right to left. This can be fixed just by flipping one of the curves. It doesn't matter. I'm going to flip it in Rhino, so I'm going to select one of them and just type flip, and then you should see the surface get untangled. Okay, so now this is the point we started to get to where we were going to use a B-rep plane intersection. So I typed in B-rep plane, and my B-rep again is any boundary container. So any surface, polysurface, you really can put almost anything you want into there. In this case, we're going to put the loft in, and we want to intersect it with a series of planes. So we made a series component, which just makes a bunch of values, a bunch of numbers for us, not just a single number like the slider does, but a series of numbers. The number, if you mouse over things here, it's going to tell you what it's actually looking for in each of the different components. So if I mouse over N or C, so this is the number of values in the series. That's going to be the courses. The step count is going to be 38.1, and then when I mouse over S, you're going to see here the metric values of 1.53, 4.5, so on and so forth. Again, the combination of this along with a Z vector actually is all you need to create a plane, because a plane only needs a point and a direction, right? It only needs a point and a vector. So the combination of these two things work together to create planes that then I can actually put into the B-rep intersect. So disconnecting something there, I accidentally put this into the loft. You right click on the component that's going in and hit disconnect. So at this point, what you should see is a series of curves that are intersecting your surface that should be perfect, that should be perfectly aligned, because the planes are driven by the same sliders that are actually defining our geometry over here. Next piece to this is going to be dividing the curves. So I'm going to put a divide, and I'm going to use divide distance. So I'm dividing these curves by a certain distance. That distance is going to be the length of the brick plus the gap between the bricks. So I'm going to make an addition component that's going to take the length and add the gap together, and that's the distance that I'm going to divide these curves by. Before I do that, I'm going to have to start treating the even and odd bricks differently, again, so that the courses can be offset from one another. In order to split up all of the curves, so right now I've got 20 curves all going in order from top to bottom. As you move up the surface, the objective here is that we want to basically split them into two lists, all the evens and all the odds. The component that you're going to use for that is called dispatch. If I mouse over it, it says dispatch the items into a list into 2 target lists. So this is basically just splitting up anything that I've got that's in a list form into 2 different lists. So what I'm going to do here is take half, or the even objects, and divide them by this distance. So if I zoom in here, you're going to see that this is good. So what you're seeing is that all the curves got divided evenly. This is because, and I'm going to put a panel on here, so this is the panel button, just allows you to see, visualize what's coming out. So what's going on here is that all of these curves are in individual lists. That's why you see them each kind of split out. Because they're in individual lists, all that the dispatch is doing is taking the first object from every list. So if I mouse over A, there are still 20 objects in there, and mouse over B, there's nothing. That's because the dispatch is looking at each individual list and taking the first object from that list. So what we have to do here is actually flatten this list, which is going to take the tree structure out of it. It's basically going to make it so that this list of 20 lists is going to become just a single list of 20 objects. So I'll right click on this and hit flatten. In order to get this, now you can see that I've just got a single list with 20 curves in it. And when I look at what's in the dispatch, there are 10 curves now in each of these things. And you can see over here in Rhino that it's actually just individually, every other curve is getting divided individually as I go up. Okay, so now to get the offset points, what I've got to do is do another divide distance. So I'm going to hit copy and paste, and I'm going to change this so that I'm actually dividing the B list, or the evens that are coming out of the dispatch. And in order to get this at every other intersection, so I'm trying to get a point here and a point here, not ones that are lined up with those. What I'm going to do is divide this value by 2, so that I'm dividing it twice as often as I was. So I'm going to put a division in, and I'm going to take this value and divide it by 2. And that's going to be my new distance. So now you see that I've got points both at the same, that are aligned with the original divide distance, which is on all the odd curves, but also here in between. And then I'm going to use another dispatch in order to actually take the points that are coming out of there and get an individual list of them that I can see. The easiest way to visualize this, because the dispatch doesn't actually show you the outcome, is to put just a point container in here. And you can see that the ones that are in A are actually aligned with the wrong, these are not the ones that we want to keep. So if I switch it over to B, now you can see these are the ones I want to keep. I can turn the preview off on the dispatch and the divide distance, and then you should see every other brick kind of offset from one another, moving up through the surface on my odd layer. So what I'm looking at now are all the points that are coming out of this divide distance are the odd ones, and all the ones that are coming out of the B on this dispatch are the even ones. And this is all I'm concerned with right now as I go to make these. Now these points aren't exactly the product that we want. We actually want to create a series of planes that go with this. So to create those planes, gotta run it again. So to create those planes that we need in order to actually place the bricks, either with here in Grasshopper to visualize it, or in Rhino in order to in order to visualize it here in Rhino, or to actually place the bricks with the robot, you're going to want a series of planes. Those planes are going to be in the XY direction. So I'm going to hit XY to get a series of planes, and we're going to put them at each of these points. So I'm going to hit Control C and Control V. And what you're going to see is that the planes get positioned at each of those points, but that the planes aren't actually running along the tangent of the curve, which we're going to want in order to get the curves to actually visualize each of the components that you're trying to make. So in order to get those aligned, we're going to use a plane align, or align plane component. I think it actually might need to be we'll try this. So the planes that you're going to align are the ones that we just made. So those will go into the P on the plane align. And then back here under divide distance, you can see there's a series of vectors that are located at each of the points that you generated with the divide distance. And those vectors are tangential to the arc. So if I put those into the align component and then turn the preview off on these other pieces, what you're going to see is that those planes are now aligned to the tangent, say in contrast to the ones that are here that I haven't done this to yet. And that's what we're looking for. So we're going to do that again here. I'm going to copy paste this one. These are the planes that we're aligning. The tangents here need to be dispatched before we put them in, otherwise you're going to have too many of them. So I'm going to copy the dispatch component and put in the tangents arcs into the dispatch. So that's going to divide them as well. And now, assuming that the data structure is the same, the letter B should represent the list that I need, and that'll go into my destination. If I again turn the preview off on these components, you should see that those planes are working now tangential to the arc that it's moving through. So now we've got the planes. These are the things we'll actually send to the robot to assemble the wall. In order to visualize this, we're going to use a box component. We're going to call it we'll use a domain box, which I think will be the simplest way to do this. The domain box needs a series of planes as the locations for each of the boxes. And I'm going to turn the preview off on these so you can see it's putting tiny little boxes in here. Each of the X, Y, and Z values are defined again in millimeters, so these are very small things right now. So a domain basically works like this. When I mouse over X, you can see that the domain is going from -2 to +2. That's going to be in the width of the brick. And the Y is going to go from -0.5 to +0.5 for a total of 1 millimeter wide. And the Z is going to go from 0 to 0.25. So we need to change each of these to match the values, the size of the brick that's back here, the length, width, and height. These values are going to have to be divided in half in order to represent the correct thing. So the X values, it appears to be, are the longer values. I think that's going to be the length. So I'm going to right click on that and say set domain. This is going to go, we want to go each direction from this plane for the value of the brick, or for the location of the brick. So this is going to be minus 101.6 to 101.6 for a total of 203.2 millimeters for the width. And that looks right. So now we've got long, skinny boxes. Now we'll go to the Y, which should be the width. I'm going to hit set domain again. The width is 89.25. We need to go half in each direction. So that's a little bit tougher. We're going to be at 44, minus 44 point, what is that? 625, I think. And then, oops, set domain, minus 44.625 to plus 44.625. Okay. And then in the Z, finally, we're going to go, these are actually, we want to start the brick at 0. So these are just going to be 0 to 38.1. That's going to actually start it at the plane and then move it up. And you can see, once we get those numbers all correct in there, that the brick wall actually looks appropriate for our 2x4 bricks moving through the wall system. There's one more component of this that I want to play around with. In Structural Oscillations by Gramazio and Kohler, what they did was actually to rotate these bricks so that they weren't all perfectly parallel or perfectly tangential to the arcs, but instead kind of kicked out a little bit to let some light and to give some texture to this. So we want to do that as well. And to do that, what we can do is just take these aligned planes and we're just going to manipulate them a little bit. So I'm going to disconnect the planes as they go into that box, and all I want to do is put in a vector rotate, or it's called VROT. So this VROT is looking for a vector to rotate, a rotation axis, and a rotation angle. The vectors that we're going to rotate are going to be these tangents that are coming out of the divide distance, and we're going to rotate them before we use them to align the component here. So these are the vectors that are coming in. The rotation axis is going to be z. Is going to be the z direction. We're rotating the bricks around the z axis, so that's easy enough. And then the angle here is going to be an angle. I'm just going to put in 90-degree slider. You'll notice that when I mouse over this, it says the rotation angle needs to be in radians. So I'm going to put in a radian component that will convert my degrees into radians, and put that in. This, I'll move the slider down to about, say, 30. Sorry, I think we could have left these intact as we did it. And what you're going to see here is that my vectors are now kind of kicking the bricks in one of the rows, in looks like the even rows, out a little bit, and I get this much more interesting kind of texture. I want to copy paste this VROC component and do the same thing. All I'm going to do, I'm going to leave the degrees and the radian conversion and the z all the same. The only thing I'm going to swap out are the vectors from the even layers, and then take the newly rotated ones and put them into the align component. So now all I've got is this slider that's going to allow me to kind of play around with the rotation of the bricks, and you can see as I pull them out, I get this kind of nice little kind of effect that's happening along the face of the wall. If you want to bring these in, if you're not aware of it, you right click on any component and hit bake. You're probably going to want to group them. And you can see here now I can switch this over. I brought them back into Rhino and I baked them, so now they're Rhino geometry that I can kind of play around with and clean up if I need to. Okay, that's the extent of this script. I'm not concerned with you actually submitting the script for Thursday. What I am concerned with is I'm going to post a little assignment. I want you to actually design a playhouse using this construction system for kids to be able to kind of play around with, as I mentioned the other day. So you're going to want to get a couple of different versions of these components working together to make a kind of small scale playhouse, as an example of what we might be able to build with the robot. I'll just kind of pan back here a little bit so you can, and I'll make this full screen so you can see the script. I don't want anybody to be confused about it, and you can kind of pause it here in order to check it out. Okay, thanks. I will see you next Tuesday. Again, I'll be replying a little bit later in the day today with whoever is going to be going to the 3:30 slot, and I'm also going to be uploading a PDF that you all need to read through before coming to the lab tomorrow to start learning how to program the robot. Thanks.